Hi, today I'm going to be talking about indeterminate uh, differences in L'Hopital's rule. Okay. One of the forms of an indeterminate difference is going to be infinity minus infinity. Okay. And to know, hey, which one's going to infinity faster? But we can only apply a L'Hopital to either this form or this form. So as you guessed it, we have to massage into one of these two forms. Okay, let me give you an example. So suppose I have this limit as x goes to pi over 2 from below of secant of x minus tangent of x. Okay, so the first thing we do is we ask for the form, and that would be to take the limit of each individual one. Remember, secant is 1 over cosine, and cosine is not defined at pi over 2. In fact, cosine limits to 0. So this 1 over 0, that's going to limit to infinity. Likewise, for tangent, it's going to be sine over cosine. So is going to have that form, sine limits to 1, cosine limits to 0, so it goes to infinity. That is the tangent. Okay. Well, let's go ahead and use that structure that I alluded to, which was that secant is 1 over cosine of x. Sine is going to be tangent is sine over cosine of x. And so now we have two fractions. The idea is to combine them into one term. And to try and massage this algebraically into one of the two forms above. Okay, well, it looks like this is one term, and now when we ask for the form, hey, 1 minus sine limits to, as x goes to pi over 2, that limits to 0. The bottom limits to 0 as well. Ding, 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 we get to apply L'Hopital's rule, because now it has one of the two forms that we can apply L'Hopital. Okay, so we're going to take the limit as x goes to pi over 2 of the derivative of the top, 1 minus sine of x, divided by derivative of the bottom, derivative cosine of x, and this is going to give us, well, the derivative of the top is going to be negative cosine of x. Derivative of the bottom is going to be minus sine of x. Okay. The numerator limits to 0, denominator limits to 1. I'm pretty sure that 0 over 1 is just going to be 0 itself. So the limit is 0. Now the key point in here is that we started with infinity minus infinity. We massaged with algebra to get in the form 0 over 0, where we could then apply L'Hopital's rule. Okay. Thank you very much.